again, the only thing, I mean, it's a z. There's nothing really you can do with this. So there's nothing to it. I think this is another typo because I got this from someone else, and it doesn't. This says because it's a z. It's not a number, and it says evaluate. So we can't really evaluate that. So I'll just skip that one too. So that's 3 that we're skipping because they don't make sense or they're not complete. Expanding the logarithms. So we're going to write this as using the properties. So log base 2 of A plus log base 2 of B squared. Now there's there's a property that says that this 2 goes is a coefficient of the log. So then we write this as log base 2 of A plus 2 log base 2 of B. And this would be the answer. The next one, 25, is 4, I believe, log base 4. So no, log base A. It's really blurry. So for 25, I'm going to put it here on the left side. So it's going to be log base A of x squared minus log base A of y z cubed, and then we break that one up even further. So this 2 becomes a coefficient of this log, 2 log base A of x, and then I'm going to break this up as a sum, so minus log base A of y plus log base A of z cubed. And this 3 is going to come down as a coefficient of that log. So the final answer for number 25 would be 2 log base A of x minus log base A of y. Notice I put parentheses because I'm keeping the denominator together, plus 3 log base A of z. If you want, you could distribute the negative to get rid of the parentheses, but it's also okay to leave it like that. For number 26, it's natural log of the square root of 3r squared s. Let me make sure I read it right. Yeah. So you can rewrite it like this: natural log of 3r squared s to the 1/2, like that, and distribute the 1/2 before you separate it. So 3 to the 1/2, natural log of 3 to the 1/2, r, because 2 to the 1/2 is 1, and s to the 1/2. So now we could separate it. So it's natural log of 3 to the 1/2 plus natural log of r plus natural log of s to the 1/2. And the final step is to bring the exponents down. So this becomes 1/2 natural log of 3 plus natural log of r plus 1/2 natural log of s. And this is as much as you do. Okay. 27, I need more space than what I have here, so I'll do that on the next, let's see if I have space here on this side. Yeah, I probably have space right here. Let me change the color so you can tell the difference. So this would be 27 right here. So we have, let's see if I could read it right, because it's the square root of x squared minus 1. The denominator, I know it's hard to see it. I mean, I think when they created this worksheet, the square root didn't go all the way across, but on the denominator, it should go all the way across. So let's write it like this. So it's going to be log base 2 of x. So log base 2 of x plus log base 2 of x squared plus 1 minus log base 2 of x squared minus 1 to the 1/2. And then we're just going to put the 1/2 to the front. So it's going to be log base 2 of x plus log base 2 of x squared plus 1 minus 1/2 log base 2 of x squared minus 1. Now you can factor x squared minus 1 and then write it as the sum of the logs of of each factor, but we'll just leave it like this for now. This is fine. Number 28. Now you're going backwards, you're combining. Okay, move this over to the right. So the first one is log 12 plus 1/2 log 7 minus log 2. So all of them are base 10, so we can combine them. That 1/2 is going to become the exponent of 7. So it's going to be log of 12 times 7 to the 1/2 divided by 2, because minus means quotient, right? So I can simplify here, and 2 goes into 12/6, and so this is going to be log of 6 times square root of 7, like that. Okay, the next one, the base is 5, and so I can write this as log base 5 of x squared minus 1 over x minus 1, but then the numerator, remember, I can factor. So this is log base 5 of x plus 1 times x minus 1 over x minus 1, so I can cancel that. So you're left with log base 5 of x plus 1. And that would be the final answer for number 29. Okay, and then we have the change of base theorem. So number 30 we're going to write as log 5 over log 2. And then number 31 is going to be log 2 over log 5. And input this into a calculator. Okay, and there are the answers for 30 and 31. They asked for it to round it to 6 decimal places, and that's why you have that many decimals, because that's what they asked for. Okay, now I could have used natural log, I just chose to write the common log, so either one's fine.